Okay, so today we're going to talk about conditional statements. We talked about compound statements yesterday, and we said there was two types. What are the two types? Conjunction and disjunction. And a conjunction are two statements formed with the word and in order for that to be true, both have to be true. And then the disjunction are two statements formed with the word or, and when is it true? One or both. Only one of them has to be true. The only time it's false is when they're both false. Okay. We talked about how to negate a statement, right? Give it the opposite truth value. Okay, so if it's true, then you change it and you make it false. Well, today we're talking about conditional statements. And these are statements that can be written in if-then form. For example, if the forecast is rain, then I will take an umbrella. That is a conditional statement written in if-then form. The conditional statement has two parts. And I forgot to give you your notes. Okay. So of course, I'm doing this deal. Okay, so now you have your notes. Okay, so the conditional statement, if the forecast is rain, then I will take an umbrella. Your statement has two parts. It has a hypothesis and it has a conclusion. Okay? We use the little mini letters that represent statements because they're statements. Remember yesterday, we said a lowercase letter represented the statement. Your hypothesis is represented with the letter P, and it's the phrase that immediately follows the word if. And your conclusion is represented with a Q, and it is the phrase that immediately follows the word then. Okay? So, go back to my conditional statement. My hypothesis is the forecast is rain. Okay? And my conclusion is I will take an umbrella. Alright, so the hypothesis follows the word if, and the conclusion follows the word Q. See these symbols here? It says P, arrow, and then Q. That is read if P, then Q. If P, then Q. Sometimes they use P implies Q, but typically I use if P, then Q. Either one is accepted. So we're going to look at some conditional statements. Sometimes, if it's not in if-then form, you have to put it in if-then form. Okay? We're going to identify the hypothesis and the conclusion, and then we're going to determine the truth value. Now, I'm not going to make you rewrite it. Just you can underline the hypothesis once and the conclusion twice. So my statement is, if A, B, and C lie on line L, then they are collinear. What's my hypothesis? A, B, and C lie on line L, and my conclusion, they are collinear. Is that a true or false statement? That's a true statement. Good. Okay, a number is divisible by 10 if its last digit is a 0. Now, this one is not in if-then form, okay? And so I need to look at it and I need to determine what's going to be my hypothesis. It does have an if, right? After if. Okay, all right. So if, and I wouldn't want to use ifs, right? Because that's my pronoun. I want to identify what it is that I'm talking about. So I would say if a number's last digit is 0, then it is divisible by 10. So then my hypothesis, we already said, is what comes after the word if a number's last digit is 0. In the conclusion, it is divisible by 10. True or false? Wait, did I say something wrong? No. So what's my truth value? True or false? Okay, it is a true statement. The number is divisible by 10. It's just going to end in a 0. I said that backwards. All right. If you divide an integer by another integer, then the result is also an integer. That's my hypothesis. Divide an integer by another integer, then my conclusion, the result is also an integer. What's an integer? Huh? A whole number, can it be positive or negative? Okay, because the whole number is positive, but an integer is a positive or a negative whole number. So if you take and you divide an integer by, let's say, another integer, 1 divided by negative 2, what's that going to be? That's going to be negative 0.5. Is that October, then this month is September. Okay, that is true. My hypothesis, next month is October. My conclusion, this month is September. Okay, what about this one? If a triangle has four sides, then it is concave. False, who thinks false? Everybody? It is actually a true statement.
What?
I know. I went and looked it up, so I didn't believe it. But if your hypothesis is false to begin with, then it kind of puts you into an imaginary world, and anything goes. Like if I said if pigs fly, then deer have wings. Well, if pigs fly, then deer could have wings, right? We're playing imaginary. You know, like when you're a little kid, what if you did this? You know, you kind of go that anything could happen. Okay? So, if your hypothesis is false to begin with, then your statement's going to be true no matter what. Okay? So, if hypothesis is false, then statement is true. So, if I said, if I'm a millionaire, then I can donate all my money to the school. Is that true? True, right? Am I a millionaire? No, but if I was, I could donate all my money to the school, right? Okay, so, if your hypothesis is false, okay, now, we talked about what a conditional statement is. And based on that conditional statement, we can come up with 3 additional statements that use if then. Okay? And this is the converse, the inverse, and the contrapositive. Okay. My conditional statement is my given hypothesis and conclusion, and I represent it with if, he, then Q. An example: if 2 angles have the same measure, then they are congruent. That's a conditional statement. If I take and exchange the hypothesis and conclusion, I flip them, and I do if Q, then P, that's called converse. So what I do is I flip-flop the hypothesis and conclusion, and now my statement reads, if 2 angles are congruent, then they have the same measure. That's called the converse. Then we have what's called the inverse. And the inverse takes the original conditional statement and it negates it. If not P, then not Q. I look here and I say, okay, if 2 angles do not have the same measure, then they are not. That's called the inverse. And then the contrapositive takes and negates the converse, or it flip-flops the inverse, however you want to think about it. Okay? So if 2 angles are not congruent, then they do not have the same measure. Now, that can be very confusing, okay, especially if it's a multiple choice question. So, what I recommend that you do is that you memorize this order. It goes conditional, converse, inverse, contrapositive. You've got to make sure you know that order really well. Then you have to memorize this order. If P, then Q. If Q, then P. If not P, then not Q. If not Q, then not P. And when you give your test, your quiz, that's the first thing you write down. Just real quickly write conditional, converse, inverse, contrapositive. And then right next to each one, if P, then Q. If Q, then P. If not P, then not Q. If not Q, then not Q. And that'll help you keep it organized. Okay? Because they might give you a statement and say, okay, what's the inverse? And then they give you 4 choices. So they have all these knots and all this, you know, rearranged in the order, and it gets really confusing. So if you've at least got this written down, you can come up with what the inverse is, and then try to go find the answer in the multiple choice. If you just try to look at the multiple choice, sometimes it just gets crazy in your brain. Okay? Alright. So, let's look at this example. It says write the converse, inverse, and contrapositive of the statement. Linear pairs of angles are supplementary. Determine whether each statement is true or false. If the statement is false, give a counterexample. Okay, so here's my statement. Linear pairs of angles are supplementary. That is not an if-then form, so I need to put it in if-then form. But before I do, I'm going to write down all my little things. I've got conditional, converse, inverse, contrapositive. Okay? And remember that the conditional is if P, then Q. Then you flip-flop. If Q, then P. And the inverse negates the conditional is not P, then not Q. And the contrapositive negates the converse is not Q, then not P. This going to hopefully help you have easier time with this. Okay, so now I've got to take my conditional statement, linear pairs of angles are supplementary, and I have to put it in if-then form. Now, typically, your subject is your hypothesis, and your conclusion is your predicate most of the time. Now, if there's an if in there, sometimes you got to be careful and think about, okay, what does this sentence mean? But it says linear pairs of angles are supplementary. So if I put this in if-then form, I would say if two angles are linear pairs, then they are supplementary. If two angles are linear pairs, then they are supplementary. Is that true or false? That's true. If two angles are linear pairs, then they are supplementary. Okay, now the converse is going to take and flip-flop that. Okay, so what would that read if I flip-flopped it? Okay, and not an angle, let's say two angles. If two angles are supplementary, then they are linear pairs. Good. If two angles are supplementary, then they are linear pairs. So if two angles are supplementary, then they are linear pairs. True or false? That one would be false. To be supplementary, do they have to be adjacent? No. Okay, so this one would be false. And I could have this 60-degree angle here, and I could have another 120-degree angle over here. Those are supplementary, but they're not a linear pair. Okay. Next one. The inverse takes and negates the conditional. So if I negate the conditional, if not P, then not Q, how would that read? If two angles are not a linear pair, then they are not supplementary. Okay. Two angles are not a linear pair, then they are not supplementary. True or false? That is false as well. We could use that same counterexample, couldn't we? It says if they're not a linear pair, then they are not supplementary. Okay. And here's the example. These are supplementary, and they're not linear pairs. So I could use that same example there. Okay, and so then the contrapositive. The contrapositive negates the converse or flip-flops the inverse. So how would I read that one? Two angles are not supplementary, then they are not a linear pair. True, is that true or false? That one's true. Okay, now we notice that our conditional and our contrapositive have the same truth value, don't we? Okay, as do our converse and our inverse. When two statements have the same truth value, they are said to be logically equivalent. Okay, logically equivalent. And the conditional and the converse will always have the same truth value. And the converse and inverse will always have the same truth value. Okay, so if I went back up here, if two angles have the same measure, then they are congruent. Is that true or false? True, right? If two angles are congruent, then they have the same measure. True. then they are not congruent. Okay? Now, these are all four true. If all four of them are true, then this is called a biconditional statement. A biconditional statement is a statement in which the conditional and the converse are both true. Here's another example. If two angle measures are complements, then their sum is 90 degrees. True or false? Two angles are complements, their sum is 90 degrees. That's true, right? If the sum of two angles is 90, then they are complements. That is true. So, this would be considered a biconditional statement. When you have a biconditional statement, then instead of writing it in if-then form, sometimes they use what's called if and only if, and they just combine it together into one statement. So instead of having two separate ones, they might say two angle measures are complements if and only if their sum is 90 degrees. Okay, so they would use the if and only if instead of you doing two if-thens, right? So a biconditional statement. And sometimes instead of if and only if, like I remember in some of my math classes they use IFF. I don't know if they still do that or not, but I do sometimes for abbreviation. Alright? So since this one up here was a biconditional statement, I could have written it as two angles have the same measure if and only if they are congruent. So I could have done it like that, and that would have told me it was a biconditional statement. And then the conditional and its converse are both true. So you can read it one way and you can read it backwards the other way, and they're both going to be true. Alright? So, remember, you've got to know conditional, converse, inverse, contrapositive. And know that it goes if P then Q, if Q then P, if not P then not Q, if not Q then not P. Write that down on your test. If you did it, you get it. Okay? That'll help you keep everything organized. Remember that your conditional and your contrapositive are logically equivalent. They're going to have the same truth value as is your converse and your inverse. Okay, we just talked about what it means to be biconditional. And then on the first page, we talked about how to identify the hypothesis and the conclusion. Okay? Alright, are there any questions? No? Okay, I'm going to pass your test out. You get a look at that. I'm going to go over a couple of the questions for the test. It won't take you very long. If you have any individual questions, I'll be happy to answer those. You guys go ahead and get started on your assignment, page 111.